Here we go. We have y is equal to c. That's a linear function. It is a horizontal line. Okay, we're going to go through parent functions today and their transformations. This library of functions you need to commit to memory. Not because, you guys, it's nothing. We never cover stuff because it's like, oh, I just think it's a really good idea. I know exactly what you're going to be expected to do on that ACT. I know exactly what you're going to be expected to do on your AP exam. Any constant will create a horizontal line. You have y equals mx plus b. You're going to get a slope. You're going to have a y-intercept. This is stuff that we've seen many times before, right? Okay. So what about other types of functions? What about y is equal to the absolute value of x? What does absolute value do to something? Makes it positive. So picture this line, okay, because we want to understand how these functions are generated, okay? If it makes it positive, then the part that was negative will flip up. That's why you get this shape, okay? Takes all those values that were negative and it flips them up. We're not going to talk about the greatest integer function or the least integer function or the what's sometimes referred to as the ceiling function or the floor function. We just don't ever see it again, so I got rid of it. Power functions, y equals x squared. That's one you're very familiar with. It's just a parabola, okay? That should be easy. You guys should recognize that right away. Y is equal to x cubed. Now that's a little bit different. Why is this parabola always above the x-axis? Because anytime you square, it's positive. But if you cube a positive, it's and if you cube a negative, it's, so really a cubic is just really a parabola with this piece flipped down, isn't it? It's kind of that same deal. Just take that piece and flip it down. There you go. Now, if I have y is equal to x to the fourth, is that going to look like the quadratic or the cubic? Why? Yeah. Now, I'm going to do just a little investigation here to show you guys what's going to happen as we increase this power and how it's going to look differently. And this could be one of the only times you're going to see this, us actually take time to do this. But if I look at, say, y equals x squared, y equals x to the fourth, I'll do y is equal to x to the, we'll do 20th there instead of 80th for right now. And I look at a graph. I've taken off the axes so we can see a little bit better view of them. Yeah. Okay, let me turn the other ones on. So we'll do x squared first, and then x to the fourth, then x to the 20th. X squared, x to the fourth, and then x to the 20th. So they all kind of have somewhat of a U shape, right? But it changes over time. It's like, well, why does it change? And notice they all go through that point right there, don't they? They all go through 0, 0, and they all go through 1, 1. Okay? But there's things that happen aside from that, and I want to show you why. If we were to plug in, for example, 1/2, what is 1/2 squared? 1/4. But if you plug in 1/2 here, you get 1/16. That's considerably smaller, right? So when you plug in x values that are less than 1, it pulls the graph further down towards the x-axis. Watch what happens when we plug in values that are greater than 1. Let's plug in 2. 2 squared. Okay, so that made it bigger. But here you got 2 to the fourth is, well, that made it remarkably bigger right away, right? So that's why you get kind of this awkward shape. Now, if this would never happen to me, but suppose I was in a meeting and I wasn't focusing and I had my calculator, I might kind of play around a little bit. And I might actually decide to, well, could I make like a perfect U shape? Maybe if I step it up to the 80th power, maybe that would happen. And so we're going to look at it. Your calculator, it's difficult for it to compute. We might break it. Oh, there we go. Looks like it didn't quite go straight up and down, huh? It's struggling. Okay, yeah. Oh well. We tried. We tried. Whatever. I exaggerated the situation. And obviously, it doesn't go all the way out to 2 and -2. We said it's 1 and -1, but that's just the general shape, okay? How about y equals x to the 5th? Do you think that's going to look more like a cubic or a quadratic? A cubic, because it's odd. So you are going to get negative values, okay? Yep. Odd ones will look the same. The even ones will look the same. They're just stretched a little bit differently. And I will not ask Grace a question on a test where she has to show a distinct difference between a 4th power and a 2nd power. No. They're pretty much, they look just about the same, okay? Now, oh, by the way, you see that difference? They always stay like this. The 4th powers, we're going to have time later on where we see that they can actually be transformed to look like that as well. But that's for a different time, okay? Yep. Root functions. Y is equal to the square root of x. Can't take the square root of a. And therefore, when you look at its graph, it just heads off like that. There are no negative values. Well, if you pick some points, like the square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3, so it gently kind of curves off. Okay. Y equals the cube root of x. You take the cube root of a positive, and you get a positive. If you take the cube root of negative, you get a cube root of -8 is -2. So you do get negatives. A cube root, you can, yeah. So what do you think a 4th root of x will look like? The first one or second one? First one. Again, I'll never tell you to try to show a difference between a square root and a 4th root function. How about a 5th root? Yeah, the cube root function. Yep, very good. Good, you guys are smart. Way to go. Let's look at some other root functions. These are ones that I really like. Y is equal to, if we look at the cubed root of x squared. Okay? Or wait a minute. Sorry, I mixed that up. We're going to look at, don't use pen, square root of x cubed. Okay? So I got y is equal to x to the 3 halves then. Okay? So the question is, can I cube a positive? Yes, and I get a positive. Can you take square root of a positive? Yeah, you get a positive. Let's think about a negative. Cube a negative, you get a negative. Can you take square root of a negative? No. So you can't plug in any negative numbers, can you? So that's why this one doesn't have anything off to the left-hand side, and it makes a gentle curve like that, almost like a parabola. Then we have y is equal to the cubed root of x squared, or y is equal to x to the 2/3. Now, think about what happens here. Can you square a positive? You get a positive. Cube root, you get a positive. Okay, so positive, positive, positive. Can you square a negative? Yeah, and you get a positive. Square root, you get a... So you can plug in positives, you can plug in negatives, but you only get out positive values. I like to call this the bird function. Kids is in the house! Okay, so I call that the bird function. Okay. Now, the last set we want to look at is our reciprocal functions, like y is equal to 1 over x. Okay. All right. Let's plug in some values, okay? If I plug in -6, what is 1 over -6? Yeah, that's a number that's really close to 0, just negative, right? What if you plug in -2? You get -1/2, right? What if you plug in -1? What if you plug in -1/2? -2. You multiply by the reciprocal and you get -2. What if you type in -1/6? You get -6. So you can see that you get this type of a shape. And for positive, it will be the same. It'll just be up here. And it doesn't matter whether it's x to the 1 or x to the 3rd or x to the 5th. Those will all produce generally that same type of shape. Notice the vertical asymptote that I have here. Where does the vertical asymptote happen? For what x value? Why? Because you can't plug in 0 for x. Very good. Now, if I look at a different function, you tell me how this is going to look differently. Y is equal to 1 over x squared. How will that look different? Why? Will it's squared, because if you square a negative, you get a. So therefore, if it's an even power on the bottom, it will look like this. So we've talked a lot about why these functions take the shape that they do. And today you're only going to focus on the real popular ones. But later on, we're going to look at the little bit trickier ones. But you want to try to commit this to memory, okay? Flip it over, and let's look at what we are going to do with them. This is a big deal. This is something you're going to use every day, basically, for the rest of the year, okay? As long as you take math, this will be important to you, what we do right now. And this is the most important part that you can consider. Vertical shifts happen when you have stuff on the outside. Horizontal shifts happen when you have stuff on the inside. So for example, if you have a function and you change it to a function plus k, that's going to affect it vertically because the k is on the outside of the function. Do you know what it will do to it? Up k units. Yeah? And if you have f of x goes to g of x minus k, what will that do to it? Down k units. So let's look at a really basic example here. Let's look at this example on g of x is x squared minus 3. What does the parent function look like? A parabola. Awesome. So what is the new function going to look like? Shifted down 3 units. Exactly. Okay? Now, I know that that's something you've seen before, but we're going to show you plenty of examples that you haven't seen before as we move along, okay? So let's look at a horizontal shift. F of x changes to g of x minus h, and f of x moves to g of x plus h. So in this situation, the change happens on the inside of the function as opposed to the outside of the function. What is the minus h going to do? Which direction? Right or left? Do you remember when we had x minus 3 quantity squared plus y plus 2 quantity squared equals 4? You said that that was, what shape did that make? A circle with a center of positive 3, negative 2 with a radius of 2. So look at your center. 3 to the right, 2 to the left. You see that? Same thing. We're just picking right up off of that. Okay? And if you see g of x plus h, then it's left h units. There is more in-depth reason of why it's opposite of what you think. If you want to see that, please come and just sit down with me. When I've tried to explain to the class, it's really just confused a lot of people. So either accept it as true, or if you want to sit down with me, I'll show you why that occurs. I've got a good explanation, but it seems to confuse people. So let's look at this. The x minus 4, is that on the inside or outside? It's on the inside. Now we know what the parent function looks like. It looks like that. So what's the minus 4 going to do? 4 to the right. And being able to generate that sketch is super important. So now, if you get that question on the test and you're asked to give the domain, you could simply just create a sketch of the graph and say, well, I know what that domain is. It's 4 to infinity, isn't it? See, today I'm trying to tie in what we did on our checkpoint. Look at that and know the domain, and also sketch a graph and know the domain. That way you have ways to check your answers. See that? Okay. This shape is going to look like that. What is the transformation? Very good. Left 3 and down 2. I'm not asking for perfect graphs. I just have to see that it's, not a parabola. It's not a square root function. I can be very forgiving. Last one is a absolute value function. What is the minus 4 and the minus 3 going to do? Right 4, very good way, and down 3. So I get that. Now, to give you guys one little bit of a hint that's worked for me, whenever I see the horizontal shift, I always think to myself, what do you plug in to make 0? What did we plug in to make 0? So it moved 4. What do you plug in to make 0? Negative 3. So move back 3. What do you plug in to make 0? So it moves right 4. That's how I think of that. What do you plug in to make 0 is how I think of horizontal shifts, and that helps me a lot. Last piece, vertical reflection. These will be on the outside. Horizontal reflection will be on the inside. So f of x will become negative g of x. See how the negative sits on the outside? If that creates a vertical flip, is that over the x-axis or y-axis? X-axis if it's a vertical flip. F of x moves to g of negative x. Is the negative on the inside or outside? Inside. So that will create a horizontal. If it's horizontal, will it be over the x-axis or y-axis? Y-axis. These are our last 4 to finish, and then we're done, okay? So, negative root of x. We all know, I love this example. One of my favorite examples we do all year. That's what root of x looks like, right? So what will the negative root of x look like? Wait, say that again, Olivia. This direction? Let's be clear and understand, okay? A lot of people want to make it go that way, okay? It's a reflection over the x-axis. It's a vertical flip, so it's going to look like this. What if it would have been y equals root of negative x? Then how would that have looked? Over the y-axis. What if it would have been negative root of negative x? Over the y and the x. Okay? This is an important one to think about and to keep in mind. And we'll come back to it, trust me. Okay? All right. 3 minus x quantity squared. Don't worry about the negative on the inside. Just follow my direction. What does the parent function look like? parabola. Instead of focusing on the negative on the inside, because honestly, you guys, in mathematics, the negatives on the inside rarely ever happen unless it's a square root function. So here's how I handle it if I see a negative on the inside. What would you plug in to make 0? 3. So it's going to move right 3. When you square this out, is it going to be a positive x squared or a negative x squared? So we'll go up, right? There you go. Don't worry about the horizontal reflection and working that out. There we go. Cube root function. What are the 3 transformations that I have going on here? Flip, right 1, up 4. Okay, so inside is horizontal. So right 1, outside is vertical. Up 4, this is on the outside, so vertical flip. If I do that, I go right 1, up 4, and we said we had a flip. Last one, what do you plug in to make 0? 5. So it's over here at 5, and what's the negative on the outside going to do? Very good. I have a worksheet for you.